In this video, we will be talking about the partial fraction decomposition. So this kind of has nothing to do with matrices, but you can solve them using matrices, but we can just do systems of equations really easily. So the way that this works, and right now it might seem really silly the way that we're doing it, and you might be wondering why we're doing this, but it's really useful in Calc 2. It's a really strong skill when we're doing integration. So just bear with this. So basically, what we really want to be able to do is that, let's say, for example, you have these two rational expressions. And what you want to be able to do is try to combine them. You want to add them. So we've done this in algebra. And the way that you want to do it is finding the least common denominator. So notice that the first one, you can multiply it by a 2x plus 1. Kind of giving it what the other guy has. And this guy, we can multiply it by a negative 1, x minus 1. Let me put this in parentheses. There, it looks a little nicer. Okay, so then when we do that, what you're going to end up with is a 2x plus 1 on the top. Now that the denominators are the same, it'll just be x minus 1, 2x plus 1. And then on the top, you're going to have a plus x minus 1. So then when I FOIL all this out, you're going to end up with 3x over 2x squared minus x minus 1. So this is kind of what you should have done in Algebra 1. But the whole point of this is that this is something that we've done a lot in algebra, but what we want to do is go backwards. So break everything into partial fractions, into their individual fractions. So how do you do this? So the goal here is to break up a rational into simple functions. And these simple functions are what we call partial fractions. Okay, and the partial fractions are actually on Canvas, so just access Canvas. I gave you guys the formulas for the partial fractions. So what we're gonna do is we're gonna start off with different cases, that, and then we're gonna and some of them are gonna pop up in the exam, so just be ready for that. So the whole point of this is that we want to be able to break them up in simpler forms. So the first one is that, let's say you have a polynomial divided by, so the top one can be any polynomial, and then you have a couple of terms, so maybe qx, let's just call it like this, qx. So you have a polynomial divided by a polynomial, and what we know is that q of x can be factored into many different terms. Okay, so you can factor it, doesn't necessarily have to be a lot of terms, a lot of factors, but let's say you can factor it into n different factors. So basically what this means, if you look at the partial fraction worksheet that I handed out, you can basically break this as a over the first term, a1x plus b1, plus b over the second term, the second factor, a2x plus b2, plus c over the third one, a3x plus b3, all the way until you get to the last one. I don't know what the nth one, so I'm going to say, I don't know, whatever this letter will be in the nth one. Okay, something like that. Okay, so you can break them up as a sum of each individual factors. Okay, so let's do an example. Okay, it's a very silly example. So find the partial fraction. So partial fraction decomposition. Okay, so you want to do it for 3x over 2x squared minus x minus 1, which is basically what we just did in the very beginning of the video. So the first thing that you want to do when you do problems like this is try to factor it. Okay, factor the denominator as much as you can. So we know that this is just going to be 2x plus 1, x minus 1. Okay, so that's what we have. So whenever you have the two linear factors, notice how we have it here that these were all linear factors. What you're going to do is you're going to set this equal to a over the first factor, 2x plus 1, plus b over the second factor, x minus 1. Order doesn't matter. You can put the x minus 1 under the a and the 2x plus 1 under the b. So the goal here is to figure out what is a and what is b. Okay? So the way that we're going to do this is that we're going to try to combine these two so that it kind of looks like this side. So we know that 3x over 2x plus 1, x minus 1 is equal to, so notice that for this first one, what this is missing is an x minus 1. You're going to multiply x minus 1 here. You're going to have a x minus 1. And for this one, you're missing a 2x minus 1, or 2x plus 1. So 2x plus 1 in here. So you're going to have plus b, 2x plus 1. And on the bottom one, you're going to have a 2x plus 1, the same common denominator. All right. So notice that the bottom parts are the same, okay, which means that the numerator should also be the same. So here at this point, you can kind of get rid of the bottom parts now that everything is together. So we're only going to look at the numerators now because this guy is basically gone. So you're going to look at 3x is equal to a x minus 1 plus b 2x plus 1. Okay, so now let's FOIL this out. So you're going to get 3x is equal to ax minus a plus 2bx plus b. Okay, and now what we're going to do is going to be something really, really weird. So we're going to try to group all of the x's together. So see how this guy has an x and this guy has an x? We're going to group them together. Ax plus 2bx. And then I'm going to group everything that doesn't have an x. This negative a and then this b don't have an a. All right. So now look at the first term. Is there something that I can factor? Yes, I can factor out an x. So I have 3x here. I'm going to factor out an x from here. So there's an x there. And now what I'm going to do is I'm going to kind of look at both sides. So because this is an identity, this is equal to each other, that means that everything, this is just a number, right? Everything in front of this x should equal everything that's in front of this x. So that means that this guy in blue, this a plus 2b is equal to what? It's equal to this 3. Okay, and what else does that tell you? It also tells you that this guy that doesn't have anything, doesn't have any x's, is equal to whatever doesn't have anything. Well, there's a 0. So that means that this green part, negative a plus b, is equal to 0. Okay? And now what we got to do, notice that you have a system of equations. Now you can just solve. A minus a is just going to give me 0. So then I have 3b is equal to 3. So b is equal to 1. Now we can just plug that into the other one. So I know that a plus 2b equals 3. So a plus 2 times 1 is equal to 3. A plus 2 is equal to 3. So a equals, subtract by, this gives me 1. So that means that a and b is equal to 1. So when you go back to your original equation, or your original thing, the partial fractions, which was this guy, I'm going to plug in 1. So basically what this means is that the partial fraction is 1 over 2x plus 1 plus 1 over x minus 1. That is my partial fraction. So as you see from the very beginning of the video, we said that that was it, right? This is the partial fractions. These were it. So yes, the process is a little more lengthier than actually combining like terms, but this is just a way that you go back to the original partial fractions. Okay. All right. So now let's do another one. So let's say you want to find the partial fraction decomposition for the following: 2x minus 1 over x squared minus x minus 6. Okay, that's what you want to do. You can pause the video if you want, or you can just work with me right now. So let's first start by factoring it. So this will be x. So this should be a 3 and a 2. This should be a minus, and this should be a plus. Okay, so what would be the partial fraction? So it will be a over the first term, x minus 3, plus b over the second term, x plus 2. I keep saying terms, it's their factors, okay, over the second factor and first factor. Okay, so now that I have that, I'm going to write it again, 2x minus 1 over x minus 3, x plus 2. So notice I have this guy, and I also have this guy. And what I want to do is I want to find the what they both have in common. So in this case, notice that this guy, I have to multiply it by n x plus 2. And this guy, I have to multiply it by x minus 3. So what you're going to end up with is 2x minus 1 over x minus 3, x plus 2. So now everything is over the same denominator, x minus 3, x plus 2. And then you have a x plus 2 on this side, plus b x minus 3 on this side. So now that I have the same denominators, I can kind of ignore the denominators. And now I'm going to have the numerators. So 2x minus 1 is equal to a x plus 2 plus b x minus 3. Okay, so now let me FOIL this thing out. So you're going to get 2x minus 1 equals ax plus 2a plus bx minus 3b. So just how we did it before, we're going to group them. So 2x minus 1. So group all the x's. So that's going to be ax plus bx. And I'm going to group all of my constants. So 2a minus 3b. Okay, so now I'm going to factor out the x. So 2x minus 1. I'm going to factor out the x. So it's going to be a plus b. And then x on the outside. And then 2a minus 3b. And then that on the outside. Okay, and then what we're going to do is now equate them. So a plus b, which is in front of the x, is going to be with this 2. So a plus b is equal to 2. And now notice that the one that has a constant is going to be equal to whatever's a constant on the other side, which is that negative 1. So 2a minus 3b equals negative 1. Okay, now at this point, what we're going to do is just multiply this guy out. So notice that the first one, I can multiply it by a 3. So I'm going to be left with 3a plus 3b equals 6. And the other one's going to be 2a minus 3b equals negative 1. So this is going to go away. I'm left with 5a is equal to 5. So then a equals 1. All right, so we got our a. Now let's figure out what our b is. So I think I'm going to plug it into the first equation. So this a plus b equals 2. That might be the easiest one. So I'm going to have 1 plus b equals 2. Okay. And now I'm going to just solve for it. So this should just be 1. Okay. Now don't get comfortable. They're not always just going to be 1. It just happened that I got 1 for both. So that means that when I plug them back in, my partial fraction, I'm going to plug in the 1 in here and the 1 in here. So my answer would be 1 over x minus 3 plus 1 over x plus 2. Okay, so that's going to be my solution. Okay, so this is basically the first case where you have kind of like the same, where you have linear factors. Now in the next one, in the next video, we're going to do repeated factors and irreducible quadratic factors.